Today, we're super duper lucky to have Zico Kolter from CMU. Welcome to the podcast.
Great to be here.
Awesome. So, Zico, you've done a lot of really, really cool stuff. And that's not me trying to be super nice. That's just objectively a fact. Chief expert at Bosch, board member OpenAI, professor, and now also head of the ML department at CMU. Used to be chief data scientist at C3 AI. A lot of really exciting stuff. Why don't you just give us like sort of like a brief 2 minute overview? Like, what should we know about you?
All right, great. Yeah, so right now my main gig is, of course, running the machine learning department and running a research group at Carnegie Mellon.
Mm-hmm.
And I focus pretty broadly there on kind of research in deep learning and LLMs and kind of the current state of where AI is.
Mm-hmm.
I think, before that, I've worked on a lot of other aspects of machine learning as well.
Mm-hmm.
One of the main topics I focus on is work on AI safety. And that's been actually sort of following a long line of work I've done dating back maybe 10 years or so,
Mm-hmm.
focusing first on kind of robustness of AI models, and
Mm-hmm.
then the advent of LLMs.
Mm-hmm.
We're kind of trying to understand where their faults are, where they can make mistakes, where they can be manipulated by third parties,
Mm-hmm.
and thinking about kind of where we can probe for the failure modes of large language models. In addition to Carnegie Mellon, I also have a startup. So I was a co-founder and chief technical advisor to Gray Swan, a startup working in the safety and security space in AI. And there we do much of the same. We sort of understand how to develop methods that can provide automated ways of assessing the security of models and then provide tools for helping companies, in fact, secure their models and ensure that they follow the policies that they want to follow.
Mm-hmm. Awesome, awesome. And I guess like we want to talk a little bit about where you grew up. I know you went to Georgetown for undergrad and
Oh,
Stanford
that's
for your
good.
PhD.
Old background, sure,
Yeah,
sure,
yeah,
sure.
yeah, yeah.
Yeah, so I mean, I grew up in Boston. Not that it
Oh,
was really
nice, nice.
the things I did, but
Yeah.
went to undergrad at Georgetown. It was funny. I went there not for a computer science program. It has a really
Okay,
small computer science
it
program, and I
does.
actually double majored in philosophy and computer science in my
Oh, nice,
undergrad.
nice.
Realized pretty quickly though that I really should be doing computer science as a
Mm-hmm.
career, not philosophy as a career, as fun as that can be.
Yeah.
Uh, so I started doing research as an undergrad there, was
Mm-hmm.
fortunate enough to find a really great advisor there that I could work with at Georgetown.
Mm-hmm.
Um, then I went to Stanford for my PhD,
Mm-hmm.
worked there on a bunch of stuff as well. Actually, I
Mm-hmm.
was not doing deep learning there. I was doing
Mm-hmm.
robotics and
Mm-hmm.
control and more classical machine learning at the time.
Right.
I did a postdoc after that at
Yep.
MIT
Mm-hmm.
and working on actually a lot of applications in AI for energy systems.
Mm-hmm.
And then I started at Carnegie Mellon in 2012, and
Right.
I've been here ever since. Some breaks here and there to work at companies and things like
Of
this,
course. Yeah.
but been here ever since. And you know, worked in a ton of different areas in machine learning. Had a chance to kind of explore different areas, explore different fields,
Right.
and lucky enough to find some sort of amazing students to work with.
Absolutely. Yeah. So okay, I guess we'll just go ahead and jump right into some really exciting questions here. So I guess first of all, academia versus industry, the age-old debate. Things have changed a lot, and I actually think you're very sort of uniquely positioned to answer this because
Mhm.
A, you are a professor. B, you chief technical advisor and co-founder of Gray Swan, which is basically an AI startup. C, you used to be chief data scientist at C3 AI, so this isn't like one company. You've tried multiple ones. And then D, you're also board member of OpenAI. And so, I mean, you sort of observed, internally also like some of the problems that, we deal with. Like, what are your thoughts on PhD students that are kind of deciding whether they should like drop out and go straight into like startups and things like that? We're kind of in like a unique perspective right now, in like unique time where there's, maybe some people like to say there's asymmetric upside to founding companies and things like that. Like, what are your thoughts? Like, is there still merit to, like staying in school? How should people sort of like decide about that?
I think it's a very personal decision at this point, to be
Yeah.
honest. And
Yeah.
I'm in academia. I'm an
Right.
academic. I've been in academia my whole life, so I'm
Right.
naturally inclined toward
Yeah, of course.
seeing the value in academia, right?
Right.
And to be clear,
Yeah.
I think we are still at a point
Yeah.
the field where the vast majority of people working in industry
Yeah.
at top research labs
Yeah.
do in fact have PhDs, right? And you
Indeed,
can argue
indeed.
this is an antiquated notion that will soon, very soon, this is going to end, and we'll all just be college dropouts that then
Yeah.
go work in AI labs. But I think there's something really valuable about taking the time to learn how to do science in a lot of depth
Mm-hmm.
when it comes to a field like AI.
Mm-hmm.
And it's not an accident that some of the best ideas come both from academia itself, and I
Mm-hmm.
think we, to be clear, I think we're still holding our own
Mm-hmm.
when it comes to cool ideas we're developing.
Yeah.
But then also, actually, I should say that with much less scaling ability than the large labs, we're still doing
Mm-hmm.
pretty well.
Mm-hmm.
But then also, I just feel like there's, whether you develop the ideas in academia or later go on to do that same or similar kind of work in a large lab,
Mm-hmm.
there's something very fundamental about learning the process of science
Mm-hmm.
through the academic environment that I think has been a has been kind of the way the innovation has worked for a very long time, and I don't see that
Mm-hmm.
changing immediately.
Mm-hmm.
I think we retain that for some time.
Yeah, that makes sense. I think like one of the things that a lot of people think about is like compute power and like
Mhm.
financials for compute, especially with some interesting things going on with politics, the administration funding for grad students recently. Like, would you say that like the prospect of having additional funding for GPU usage, and basically more compute power is like a big advantage in industry versus in academia? And like, if it is a big advantage, like, how do you think that people in academia are still able to make like sizable contributions on the applied side?
Right. So of course, academia is not going to be at the same scale as
Right,
industry when it comes to compute resources, right? I
right.
mean,
It's the
this is
fact. Yeah. Yeah,
this
yeah.
is going to remain the case, right?
Yes,
We're
yes.
not going to catch up and all of a sudden have hundreds of thousands of GPUs
Yeah, yeah.
available for a PhD student project. And as we shouldn't, right? Because academia is about fundamental research, it's about
Yeah.
sort of basic science,
Yeah.
and the GPUs are needed at this point, not just for basic science, but really for
Yeah.
scaling this to the level that it needs to sort of be at the true cutting edge of this slice of AI.
Right.
Um, so yes, you're not
Yeah.
going to have as much compute in academia
Mm-hmm.
as you will in industry.
Yeah.
Having said that, I think that the one amazing thing about the field of AI right now is that
Mm-hmm.
we do have this property of scaling laws, right?
Right, right.
And so what that, I mean, for those that aren't familiar with this,
Yeah.
what that means is sort of AI models follow a very predictable behavior when it
Mm-hmm.
comes to their improved performance when
Mm-hmm.
you invest more compute,
Mm-hmm.
right? So I mean, you can't extrapolate from tiny models. You can't run it on your laptop and try
Right.
to extrapolate what happens, when you run it on 100,000 GPUs.
Right.
But if you have a reasonable setup, at
Right.
Carnegie Mellon, in our current cluster for the department and a couple departments, we have 800 sort of, kind of consumer grade GPUs and then 256 H100s.
Mm-hmm.
And if you're able to run kind of at that scale and
Mm-hmm.
scale up to that amount,
Mm-hmm.
then you can very reliably extrapolate the performance of your methods as you scale out further.
Mm-hmm.
Well, first of all, you can actually generate very useful artifacts. I mean, a lot
Mm-hmm.
of small models, I mean, 8 billion parameter models, stuff like this, not that small,
Mm-hmm.
very large as of a few years ago, but now all of a sudden small. They're trainable
Mm-hmm.
to some extent with this scale of compute.
Mm-hmm.
But then more importantly, it's really the case that you have this ability
Mm-hmm.
to show trend lines.
Mm-hmm.
And I think more and more good academic research is going to need to show scaling performance.
Mm-hmm.
And when you do that,
Mm-hmm.
and you show scaling performance in a regime that gets, even at the low end of what you might see at a large lab,
Mm-hmm.
you give yourself a lot of credibility and a lot
Mm-hmm.
of sort of evidence that
Mm-hmm.
this method will in fact be one that scales well,
Right.
that actually does become valuable and more valuable as you increase the compute.
Mm-hmm.
And so I think that ultimately, we're going to be able, just like in a lot of fields,
Mm-hmm.
we're going to be able to demonstrate value of ideas
Mm-hmm.
that if they do in fact seem promising,
Mm-hmm.
industry will want to pick up.
Right.
That's sort of number one.
Okay.
The second thing I would say, though, I mean, this is going to be even more important, is that there are all sorts of portions of the field
Mm-hmm.
or aspects of the field
Mm-hmm.
where there really is just direct need
Mm-hmm.
for academic fundamental research. I think especially when it comes to things like safety and security,
Right.
when it comes to things like evaluations, specifically evaluations that go beyond sort of simple answer checking, right? So evaluations of more complex, hard to grade behavior. All these things still need fundamental research, and they can benefit heavily from continued investment from our academic community. And I do think academic research will continue to have an impact on the field
Yeah.
and to sort of guide a lot of the fundamental directions that we see in the field.
Yeah.
Of course, at this point, well supplemented by, and in many cases, sort of necessarily
Yeah.
in tandem with industry, because industry clearly is driving a large portion of the actual experience we have of AI these days.
Mm.
But I believe that there is still value in academic research
Okay.
fundamentally.
Totally makes sense. Completely makes sense. All right. So for context, I mean, a lot of people in the audience, right, like pretty predominantly incredibly technical. People engineers, researchers, PhD students, master students, and really exceptional undergrads. So they all sort of come from a technical background, but maybe lack a little bit of context on maybe like the entrepreneurial side of some of the things that you've accomplished as well. To just give some of them a little bit of like background. So Zico's done a lot of really exciting stuff in like robustness and certification, neural network verification, modular optimization within deep learning, but then also some applications in domains like energy systems and sustainability, and then obviously safety, which we've talked about, and like LM security. So there's this big trend approaching called AI for science, which actually has occurred for a while, but like it's becoming even bigger now. Like what are your thoughts there, and like specifically related to safety?
Yeah, I'm incredibly bullish on AI for science as a
I had a
whole.
feeling. I had a feeling.
Yeah, of
Yeah.
course. I
Yeah.
mean, look, I think as much as I believe that there is need for fundamental work in AI
Right.
in academic environments, I think it's also very much the case, and arguably even more the case,
Mm.
that more work will be needed in the application of AI to other academic fields,
Yep.
right? Only a small portion of the actual
Yeah.
academic world is working on core AI techniques,
Yes.
right?
Yes.
The
Yes.
vast majority of the academic exercise is, in fact, a scientific one, right? We are the scientists. We're advancing basic research in many, many fields,
Mm-hmm.
many of which are not nearly at the point of AI where it's so easily commercializable.
Mm-hmm.
These are things that, where innovations can take 5, 10 years from, basic idea to even having a paper out.
Mm-hmm.
And so fundamentally,
Mm-hmm.
I am of the opinion that the mission of academia, the mission of the scientific community,
Mm-hmm.
which I include myself as one, even though I
Mm-hmm.
don't work in the hard sciences,
Mm-hmm.
is going to be one of taking the techniques we've developed that we are all developing right now,
Mm-hmm.
and understanding how to leverage these for advancing all aspects of science, all
Mm-hmm.
fields of science,
Mm-hmm.
because there is
Mm-hmm.
so much work to be done
Mm-hmm.
in basic science. I mean, there's
Yes.
just so much that we don't know
No.
yet,
Yeah.
and so much practical things we don't know yet. I mean,
Right.
I work with, or I don't work with, but I have colleagues, for example, that
Yeah.
work on things like nuclear fusion, right?
Right.
I mean, the applications there are sort of these are still long time horizon things.
Mm-hmm.
I think can be potentially greatly accelerated through the use of AI, but
Mm-hmm.
these are still relatively long time horizon things
Mm-hmm.
compared to the next model update and stuff like this.
Mm-hmm.
And these are things that still require very fundamental research to sort
Mm-hmm.
of really build out the basic underlying principles of this
Mm-hmm.
technology. And that's just to pick one of many, right? I
Yeah.
mean, it's an infinite number of things in biology and chemistry and materials and under basic physics, stuff like
Yeah.
this. There really is no shortage of incredibly important problems,
Mm-hmm.
and I do think that a big portion of the next decades to come, the
Yeah.
next decade, next 2 decades,
Yeah.
is going to be less about fundamental. Maybe
Yeah.
uh, I personally think we're kind of
Yeah.
we're already there in a lot of respects, and even if
Exactly.
there's more fundamental AI
Yeah.
advances, there's still what we have so far is already so useful
Yeah.
that just by taking it and taking its next evolutions
Mm-hmm.
and applying them
Mm-hmm.
and leveraging them in basic science,
Mm-hmm.
we're going to create revolutions across the board, or we could create revolutions across the
Right.
board if we put in the time and effort. And so I think
Yeah.
that's where the future is most likely to lie.
Sure. Sure.
And so yeah, we have to just do the work. And
Sure.
so I'm
Totally.
very bullish. Now there's of course, this work has to be done in conjunction with scientists, right?
Yes.
We should
Yes.
not
Yes.
go out and do these things ourselves. We
Yes.
should be heavily partnering with
Yes.
the basic science. But I really think we have something to offer. I think AI
Mm-hmm.
has something really, really powerful to offer.
Mm-hmm.
And it should be done in the spirit of, very, very active collaboration
Sure.
between basic AI research and the fundamental sciences.
Mm-hmm. Awesome. So I guess another aspect of this, like, Noam Brown gave a talk at CMU, in the fall, I want to say, and he talked about how like one of the key barriers to quote unquote AGI is like memory. You work in safety stuff. Obviously, like that's really important, robustness and safety of these models. There's a lot of work done under, like red teaming and things like this as well. You want to like mention like some of the things that you think are sort of needed to reach AGI? Like you sort of have, like whether we need new architectures past transformers with test time RL to actually reach AGI, or there's some other factors?
I definitely don't. Okay, just to preface all of
Yeah,
this, this is my own personal opinion
sure,
now, and I think a lot of disagreement about this in the academic
sure.
community,
Yeah,
but I'll give you my opinion.
sure.
I think that the current directions we are pursuing right now
Mm,
will get us to AGI.
okay.
I think it will. I think that the hurdle,
Mm-hmm,
the basic insight that came with this notion that if you
mm-hmm,
apply a big enough architecture
mm-hmm,
to predict text
mm-hmm,
and then turn that process loose,
mm-hmm,
that produces intelligence. And I
mm-hmm,
think that is a discovery, to be clear. It's not a engineered fact. It's a discovery we made
mm-hmm,
about the nature of the world. That was probably one of the biggest hurdles to overcome. And now
mm-hmm,
that we've done this and we've sort of started to build a scaffolding around it, I think getting very, very far toward what all of us would call AGI, or at least what all of us would call AGI,
mm-hmm,
by any other name
mm-hmm,
5 years ago, if we weren't so inoculated,
mm-hmm.
day by day about all the advances we see every single day.
Indeed.
I think we're going to get to AGI.
Mm-hmm,
I do. I don't know when, and I think a lot of when depends on sort of your definition of AGI, which
mm-hmm,
and there are different definitions people kind of
mm-hmm,
internally in their mind use for it,
mm-hmm.
but I think we get there.
Awesome.
I think that transformers will work just fine for it. They
Okay.
might not be optimal for it.
Right.
I don't kid myself that transformers are somehow discovered as the optimal architecture, but
Right.
they're sufficient for it, right? They're good
Mm-hmm,
enough. And
mm-hmm,
frankly, a big lesson of the past many years
mm-hmm,
in deep learning, and in my view, is that architectures really don't matter all that much.
mm-hmm,
You need a few properties of an architecture to work well, but it doesn't really matter.
mm-hmm,
Had transformers not existed, we could have all been doing the same thing with different types of convnets
mm-hmm.
or recurrent networks or state space models now.
Yes.
We can do it with all
Yes,
of them.
yes,
They all
yes.
will work fine. It's
Right.
not about that. It's about the data. It's about the sort of process by which you train these systems.
Mm-hmm,
Architectures don't matter. They're
mm-hmm,
irrelevant. I mean,
mm-hmm,
they matter in the sense that there are of course differences, and transformers are a good architecture. They're
mm-hmm,
good at soaking up this data,
mm-hmm,
but they don't matter in a fundamental blocking or non-blocking
mm-hmm,
fashion. They're a
mm-hmm.
matter of efficiency and kind of nicety.
Right.
Um, and so I think we're going to get there. I
Okay.
think we're going to get there with the current architectures, with additional engineering, with
Mm-hmm,
additional tooling, additional data,
mm-hmm.
but all these things that that we're very much making progress on, we will get to this stage, I believe.
Yeah, awesome. And also, like, I mean, you as a person have this very strong interest in safety and robustness. So that's why I'm about to ask this question.
Mhm.
Like, policy, job displacement, et cetera, et cetera. There are a lot of like quote unquote worries, especially people who don't know much about AI are very much like, oh, it's Terminator, AI is going to take over the world, it's et cetera, et cetera. And so there's a lot of this sort of like negative sentiment. But I mean, even in industry, right, we're sort of seeing some like very like maybe the early innings of job displacement with engineering being a lot faster because of code generation tools and things like this. So from your perspective, like how do you tie in safety and like your recent work and some of your preprints that you've been doing on like LLM security and things like this with like really thinking like safety pre-training? I don't think you have a paper on that recently as well. Like how do you tie that in with thinking about where society is headed? Like,
Right.
yeah.
So look, I think to a certain extent, these things are related, but they're also in many cases touching on
Right.
separate orthogonal issues, right?
Exactly.
So when I
Yeah.
talk about sort of LLM security and LLM safety,
Yeah.
what I'm really talking about is the ability to make models follow a given policy.
Yep.
Developers have some desire. You want an
Right.
LLM to do this and not do this.
Exactly.
OpenAI has their model spec. This is
Yeah.
a list of things that they want the model to do and they don't want the model to do. This
Mhm.
is very useful to have this actually and sort of publish this, I think.
Mhm.
Now, I do think that there are aspects of which, there is an extent to which
Mhm.
this technical security and technical safety
Mhm.
will of course impact downstream effects of the sort of the repercussions
Yes.
of LLMs, right?
Right.
If they are better at following policies,
Mhm.
some of the most negative consequences absolutely can be avoided of these
Mhm.
things.
Mhm.
However, when it comes to sort of more, I would almost use a different word, like evolutionary risks, right?
Right.
The risks just
Indeed.
come with a new technology,
Yes.
especially if it's a powerful technology.
Yeah.
These things are going to happen whether that technology is secure in the sense I'm talking about or not, right?
Yeah.
Like a very safe, secure technology is still able to do a lot of work,
Yes.
and usually result in displacement and things like this.
Yes.
But I also believe that the way I'll put it is that I think that companies who look at the progress in LLMs
Mm-hmm.
and say, "Oh wow, I can get rid of a lot of people," that's probably actually a really bad idea. You
That's
should be
funny.
instead
Let's
saying,
make it more efficient.
well, look, I don't know any company. I've never felt like my work is done for the day when I go home, right? I
Right.
don't
Right.
know any companies that sort of say, yep, we've accomplished everything we want to accomplish.
Mm-hmm.
Nothing more else we could do
Mm-hmm.
with more workers, with more free time,
Mm-hmm.
not free time, but with more time that our
Mm-hmm.
workers have. There's nothing more we could do. We're just done, right?
Yeah.
There's untold things left to do
Yeah.
in most companies, and there's untold abilities that we are now unlocking
Mm-hmm.
with the proper use of this technology.
Mm-hmm.
And so I think the right way to think about this is to
Mm-hmm.
think and say, look, we are entering an era where there's a profoundly new set of tools and techniques that we all have at our fingertips.
Mm-hmm.
Um, I don't think the companies that thrive in this new environment are going to be the ones that say, how do we cut as many workers as possible? How do we sort of use that
Yeah.
technology to sort of reduce our costs as much as we possibly can?
Yeah.
I think the ones that are going to succeed are the ones that say, we have this amazing new technology. What amazing new things can we do?
Mm-hmm.
Given our current resources, given more resources, given these new things we have,
Mm-hmm.
the ability to be however many more times productive, et cetera, in our
Mm-hmm.
workforce, what massive new things can we accomplish?
Mm-hmm.
And I think that mindset, that sort of
Mm-hmm.
mindset of what amazing new things can we do,
Mm-hmm.
what new things can we build,
Mm-hmm.
that's going to be the companies that adopt that mindset are going to be the ones that succeed.
Mm-hmm.
And ultimately, I think that will create sort of a better working environment and ultimately growth in all facets
Mm-hmm.
that I think is ultimately going to be a positive thing.
Mm-hmm. Awesome. Okay. So we're getting close to time, so we'll end with two questions. One, I think you had a paper recently on how much models are memorizing versus understanding slash reasoning, and this is also something that, well, I think a lot of researchers are thinking about this. I've been seeing a lot of papers about this. Any like sort of quick points that you want to touch upon this because I think it's become a pretty big deal recently.
Yeah, memorization takes on a bad connotation in the
Okay.
context of AI models for a few
Mm-hmm.
reasons.
Yeah.
The first is that there's this notion that if you train a model on any data, it has memorized that data,
Mm-hmm.
and so therefore is somehow constrained by it in a fundamental
Mm-hmm.
way, or that it might violate things. It might sort of
Security.
violate fair use and things like this, right?
Mm-hmm.
Um, but I think it's important to understand that I don't believe, and I think you actually can prove mathematically
Yes.
that LLMs memorize all the training data. In fact, you can
Exactly.
show this very easily
Yeah.
because the training data as a whole, these models have fewer parameters or fewer bits in their parameters than a compressed version of the training set. They
Mm-hmm.
can't actually be memorizing at all, right? So
Yeah.
they are actually fundamentally creating a compressed representation,
Mm-hmm.
which is exactly kind of what I would call sort of synthesis and intelligence to a
Mm-hmm.
certain extent from the
Mm-hmm.
training data, right?
Mm-hmm.
Now, do they memorize some things? Yes, they can repeat some things verbatim because sometimes it is also good to memorize things. Just like, by the way, humans also memorize some things, right?
Mm-hmm.
If we see it enough times, we just memorize it.
Mm-hmm.
Actually, very similar to what they do.
Mm-hmm.
Um, the fact that they memorize things, which is
Mm-hmm.
true,
Mm-hmm.
is orthogonal to the question of whether or not they understand or can reason.
Okay.
I think very often people use the fact that they can memorize and that they
Mm-hmm.
are based upon training data
Mm-hmm.
to somehow, in a leap of logic,
Mm-hmm.
imply that they are not thinking or that they are not reasoning or they are not XYZ. You
Mm-hmm.
know, unlike obviously they must not do that because they're just based upon predicting text and things like this, but
Mm-hmm.
it's just fundamentally untrue in my
Mm-hmm.
in my
Mm-hmm.
view, right?
Mm-hmm.
The measure for understanding and reasoning is sort of about what you can accomplish. I
Mm-hmm.
mean, we have no, these are very amorphous questions that
Right.
philosophers have spent a long time thinking
Yes.
about.
Yes.
And part of the reason, that tests like the Turing test were so great is that
Yes.
they took the philosophy out of this and made this an empirical test.
Mm-hmm.
And so I think when it comes to things like understanding and reasoning,
Mm-hmm.
we have good notions of what we think these mean in the context of humans.
Mm-hmm.
LLMs are able to accomplish many of these things.
Mm-hmm.
By the way, yes, in new scenarios,
Mm-hmm.
then sort of what they're presented with in their training set.
Mm-hmm.
And so in my mind, this is clear evidence for understanding and for reasoning.
Mm-hmm.
They also memorize, to be clear.
Right,
They also
right, right.
memorize.
Yeah.
Not everything, right?
Yes,
Definitely not
yes,
everything,
yes,
to be clear,
yes.
but they do memorize,
Yeah.
famous quotes and stuff like this, right?
Mm-hmm.
And so I think that there's just, there needs to be a science, and a lot of what our papers do really is they try to present a scientific kind of mathematical
Mm-hmm.
definition and view of what memorization is.
Mm-hmm.
And there needs to be this. We do need a mathematical understanding of memorization,
Right.
but I want to emphasize that this is not about sort of a rather this is not about kind of quantifying
Mm-hmm.
what they memorize versus understand.
Yeah.
It's just quantifying, what they do sometimes memorize.
Mm-hmm.
And so I think this is an important distinction to be made.
Gotcha. All right. Well, we're pretty much almost at time. So, very last question here. There's two sort of groups of people that this podcast is aimed towards. Like one is sort of academics, so let's call it PhDs, even actually faculty, postdocs, so on and so forth, and master students, undergrads that are doing research. And the second is people in industry that are sort of quote unquote AI engineers, which in many cases is really just engineering, sort of using API calls from other different model providers. So for these two different populations, one that's more research oriented, one that's more industry AI, applied AI entrenched in some really deep domain, like what's your advice for them?
Um, I think the advice is actually pretty that I would give in practical terms
Yeah.
is actually pretty uniform across both groups.
Okay.
Presumably, these are groups that are all well. Actually, I take that back.
Okay.
Not everyone in these groups is actually using AI that much,
This is
right?
true.
The
Yes.
first bit of advice I give everyone,
Yes.
novices, doesn't matter what field you're in,
Mm-hmm.
is just to start using these tools a whole lot more than you are right now. If you're not using them,
Yes.
already a lot.
Yes.
I use AI tools every single day in my
Yes.
life. They are super useful. They
Mm-hmm.
make me more productive. It's kind of like a superpower. And if you're
Mm-hmm.
not doing it, you're sort of leaving you're leaving productivity on the table, basically.
Yep.
And in fact, despite all their flaws, you should be using them precisely
Mm-hmm.
because you need to understand what things they are currently good at and
Mm-hmm.
things they are not currently good at.
Mm-hmm.
And hence, as they evolve and get better at things, you will sort of also evolve along with them and start using them more.
Mm-hmm.
Now, for those that are already kind of using these things and,
Mm-hmm.
and are very familiar with them,
Mm-hmm.
the other bit of advice I would give, and this is maybe more the industry crowd, because actually
Okay.
academics need to use them more, to be
Yes.
honest.
Yes.
To the industry crowd, the thing I would say to this audience is learn the fundamentals of how LLMs work, how machine learning and hence LLMs
Okay.
work.
Mm-hmm.
The math that you need for these things is not hard. It's
Mm-hmm.
high school level math.
Mm-hmm.
The code, the entire code for a
Mm-hmm.
brief implementation of a language model is inference only is probably I know it's 100 lines of Python
Mm-hmm.
because I have people implement it in my class.
Mm-hmm.
For training and inference, it's maybe 200 lines of Python. This is not complex systems. This is
Yes.
actually incredibly simple. It's amazing how simple they are,
Mm-hmm.
and they're beautiful because they are so simple.
Mm-hmm.
Take the time to just implement these, even if like you're not gonna implement your own LLM and train your own LLM, not for that reason, but because it's valuable to understand the math behind this, and it will give you a deeper appreciation for just the fundamentals of how they work. Even, by the way, if it doesn't actually help you use them better,
Mm-hmm.
it is still fundamentally interesting. The fact that you can write an LLM in 200 lines of Python, more or less, with libraries, of course, right? With
Yes. Yes.
PyTorch
Yes.
itself pretty large, but it's amazing that you can write it in that little time or that little code. And that is sort of beautiful in itself. And I think doing that exercise and seeing just kind of how small the kernel of knowledge is that creates these amazing artifacts is a really humbling experience. And it's one that every developer that works with AI at some point should do in their lives. Again, it's not hard. You can do it in a few weeks. You can learn the basics, implement it, go from there. You should be doing it. And that's the thing. That's the advice I would give for most people in industry who work with LLMs.
And for researchers, you think that they should just use AI tools more?
Oh yeah, it's sort of the dual thing, right? Most people in
Yeah.
the industry are using them all the time,
Yeah.
not learning how they work.
Yeah.
Most people in academia are just learning how they work and not actually using them. They look
Gotcha.
into the other
Gotcha.
one a whole lot.
Gotcha. Totally makes sense. Totally makes sense. Awesome. Well, thank you for your time. Really, really appreciate it. I think lots of really great advice that you had. So, yeah, thanks for your
Great,
time.
great being here. Thanks for inviting me.